Thanks, and welcome everyone to part one of Databricks for data engineering, part one of a two-part series. Basically, there was too much to cover in the sort of depth that we wanted. It would have all been too condensed. So we thought in this part one, we could give sort of overview, context, dive down a little bit, but in part two, really dig a little deeper into some specific topics. Running today's webcast is myself and my colleague, Liam. So we're both consultants, BI and analytics consultants based out of our London office. We both have extensive experience with data engineering projects using Databricks. Liam's experience mostly lies in the pharmaceutical industry, but also he has experience in CPG as well. My experience is mostly in CPG, consumer packaged goods, but I also have experience with data engineering in finance and with insurance as well. And our details are up there should you want to contact us about anything after this webcast. So for the agenda today, I'll hopefully cover it in only a few minutes, just a quick introduction to Thorogood and a quick Databricks overview to sort of set context. And then I'll hand over to Liam and he'll discuss the cluster, which is really the power behind Databricks. And then he'll hand over to me and I'll run through sort of where Databricks fits in terms of general data architecture for use in data engineering. I'll show how it syncs with Azure and AWS, and both of our sections will include demos. So we feel like that's the sort of best way to illustrate how Databricks is beneficial, and it's always better to see the tools in action. So about Thorogood, we're an independent company, business intelligence and analytics specialists. We are a technology company, but really we're a business consultancy which offers technological solutions. We serve global customers through our headquarters in London, but then also all of our offices elsewhere in the world, from Philadelphia to Singapore, Sao Paulo, and Bangalore as well. Primarily, we're offering solution design and development, but there's a lot of sort of different aspects around data and analytics that we offer as well. So obviously there's that solution design and development, but additionally we offer sort of advanced analytics services, planning and business modeling, user empowerment as well, so upskilling organizations to use the technologies themselves, as well as offering advice on sort of strategies and roadmaps going forward and sort of data roadmap plans for organizations as well. And particularly relevant to this webcast, we partner really closely with the sort of big tech vendors. We're independent, which means that we're allowed to sort of choose the best tool for the job. We're not biased in any way, but we're really close to technology through these partnerships. So obviously relevant to today, we're really closely partnered with Databricks, but we're also really closely partnered with Microsoft and with AWS as well. As you can see, we've got 5 gold competencies in Microsoft, including Gold Cloud Platform. And then we're partnered with these other tech vendors that are listed up there as well. If you've never heard of Databricks, this is a sort of overview of what it is. It was founded by the same team who created Spark, and it's really an enterprise platform for Spark. It offers a better user experience, easy integration with Azure and AWS, easy sort of startup as well, and just a general better user experience for enterprise level organizations to just implement immediately. I see it as really just Spark, but formalized. Then Databricks themselves describe themselves as a unified analytics platform. By that, it's really one area where you can run both your data engineering and your data science. What allows you to do both in a really effective way is sort of 3 key points. And the first point here is that it's cloud-based. So there's sort of 2 options of Databricks you can have. One is Azure Databricks, and the other one is just Databricks. But actually, that's linked through AWS, and the compute power comes from AWS, and the storage would be from AWS as well. And obviously, there's a huge move to cloud. The benefits I won't go into right now, but it is obvious as sort of being able to scale up, and it's cost effective. But basically, Databricks is the sort of tool that will allow you to really tap into cloud technology for data engineering and data science. Databricks also auto scales. So that means 2 things really. The first thing is that for any workloads, it'll match the compute power to sort of get the load done. So if you ask a lot of it, it's going to scale up its sort of capability. But likewise, if you're asking less of it, it'll scale down as well, and that'll help you sort of manage costs as well. So basically, it's flexing to what you're asking of it at the time, which is a really useful aspect of Databricks. And finally, what also benefits data engineering and data science are the notebooks. Their structure and design is very easy to follow. There's a lot of sort of additional functionality, but most importantly, you can use one of 4 languages, Scala, Python, R, and SQL, and we'll show that through the demo. And you can switch in the same notebook to those different languages as well. And then data engineering, as I said, it's linked in really well with Azure and AWS, so it allows you to really use Databricks as your primary data engineering tool throughout your data lake. And then Databricks created Delta Lake, so obviously Databricks is really good at handling Delta Lake files and sort of implementing Delta Lake really easily as well. And then obviously this is a data engineering webcast, but we should touch on the data engineering side. Multiple ML frameworks are pre-installed in Databricks, and also Databricks has MLflow for managing all these life cycles as well. So that's a sort of overview of Databricks. Now I'll just hand over to Liam, who's going to cover the Databricks cluster, including how it works, how to set it up, and generally using the Databricks notebook as well.
So let's start by talking about Databricks' distributed data processing. So this is an Apache Spark native design, and it's part of what makes Databricks so suitable for big data processing. So essentially, this is the architecture that Spark commands will use. The idea is that the work will be divided among a number of worker nodes. Final results will be compiled, which allows for parallel processing and therefore much faster speeds. So first we have this driver program. Now the driver program consists of the user's code and the Spark context which you set. Now the driver node will maintain all of the relevant information throughout the lifetime of the application. This is known as the state. And essentially the driver program will declare the operations on the data using RDD transformations. So that's resilient distributed data set transformations and actions. And so essentially what it's doing is it's translating your code into a format that can be applied to data sets which have been distributed across worker nodes in the way that Spark does it. So depending on the Spark context, it will connect to a particular cluster manager, and then it will submit the required RDD operations to this cluster manager. So, the next aspect here is the cluster manager. So the cluster manager controls the physical machines, and it allocates resources to Spark applications. So what cluster manager you get depends on the Spark. Depending on the Spark context, you'll get either a standalone, Apache Mesos, Hadoop Yarn, or Kubernetes. And this cluster manager, the role of any of these cluster managers will just be to divide these RDD operations submitted by the driver program into tasks which can then be allocated to the worker nodes. Here the tasks are then divided amongst these worker nodes. So a worker node hosts an executor, and this is responsible for 2 things: executing the code which has been assigned to it, and then reporting the state of that computation back to the driver node. So let's take a look at a demo of how we can set up a cluster in Databricks and just some of the options within it. So here we're at the Databricks homepage. We now navigate to the clusters pane along the left-hand side, and now we're going to click Create a Cluster. The first option here we get is on cluster policy. So this option will only actually show if you have at least one cluster policy created. So we've created one earlier. And essentially this is the way to apply access restrictions and limitations on this cluster configurations page. So it's limiting who and what people can do on this cluster configuration page. So in this case, we're going to select freeform. This means that there will be no restrictions. There's no policy restrictions. So we're going to call the cluster DB for DE, Databricks for Data Engineering. And next, let's look at the modes you've got. So there's 3 modes. Standard is recommended for single users by Databricks and can run all of the languages that Databricks supports. So that's Python, R, Scala, and SQL. Now, high concurrency, on the other hand, this is optimized for multiple users who will be sharing a cluster. So it's optimized in terms of how it allocates the resources, and in terms of the query latency. But this will only work for SQL, Python, and R, and it does not support Scala. So that's something to keep in mind when you're selecting your modes. Single node is not so widely used. Essentially what this means, if you refer back to the slide we previously showed, this will run everything off the driver node, and it has no workers. It runs all of the jobs through the driver node. And this is good for single node machine learning workloads that need Spark, or just for lightweight EDA, lightweight exploratory data analysis. So in this case, we're going to just select standard. And it's worth keeping in mind that you can't change your cluster mode once it's created. You'd have to create a new cluster to do that. So this pool here, this is quite a new feature. And so the idea of these pools is to reduce cluster startup time. So essentially what happens is you attach a cluster to a predefined pool, like the one we've created here. This is a predefined pool of idle instances, idle cluster instances. And so when a cluster is starting up, when you want your cluster to start up, it will try to allocate the required resources from that pool of idle instances, which will have a quicker startup time. And if this pool does not have sufficient resources, what it'll do is it'll allocate new instances in the usual way from the instance provider. And then when this attached cluster is terminated, those new instances that it's provisioned will be returned to the pool. And so in the future, the pool will have a larger pool of resources, of idle resources that other clusters or this cluster could access. So that's something to keep in mind if that's important in your use case. So the next one here is Databricks runtime. Databricks runtime is essentially the set of core components that run on your clusters. And so this includes different versions of Scala and Spark, and has additional features within it to kind of improve usability, performance, and security in particular use cases. So you can see that some have been optimized for ML. There's all kinds of different options here. So in this case, we're just going to select the most recent one, runtime 7.5. So if we look at this, these options at the bottom, so this should be familiar. This is what we covered previously. We'll have the driver nodes and we'll have the worker nodes. And so here's where we can kind of customize these driver and worker nodes. Now, in most cases, in most use cases, you would select the same type for the driver and worker node. And it's really about just selecting the right type for your use case. So you've got to consider the size of the data sets, the nature of the transformations. Is it memory intensive? Is it processor intensive? Either way, you'd have options here: compute optimized or memory optimized, which would allow you to kind of customize your solution. And so obviously the cost will vary depending on the amount of processing power and memory that you're providing. And just to touch on a final bit here, so this is auto scaling, this button here. And so Robbie touched on this a bit. So if we untick the auto scaling button, we're going to select a fixed number of worker nodes, and Spark will just ensure that those workers are provisioned. Now, if it is ticked, what we're going to get instead is we're going to get a range of workers. So we'll provide Spark with a range of workers, and it will automatically choose the appropriate number of workers required to run that particular job within that range that you provide. So this can be really good for kind of cluster utilization, and as Robbie said, just managing costs, as it won't provision more than it needs. So instead of creating this cluster, we're going to use one that we created earlier. So this is DB for DE. And now what we're going to do is we're going to look at a notebook which is using this cluster. So first, if you wanted to create a new notebook, you could just navigate to this workspace panel on the left-hand side. And here we can see all the folders that we've created. And if you want to create a new notebook, you navigate to Create Notebook, provide a name. And then here we have the default languages that this notebook will use. It doesn't mean that you can't use other languages. It just means that this is the default, and any other ones you would have to use the magic command in order to use a different language. And here we're attaching the cluster DB for DE that we've created. So here we go. Let's navigate to this notebook. Right, so as you can see, there's 2 cells within this notebook. It's attached to our DB for DE cluster. And hopefully we're not going to have an issue here, as this should just be running, but we'll see in a second. So essentially, we've got 2 cells here. So what we're going to do is we're going to try and run these cells. Okay, unfortunately, we're having an issue where the cluster has started restarting. Oh, there we go. Good timing. So we've got 2 cells here, and what these cells are doing is essentially they're going to read in a CSV file that we've stored in a storage layer. So let's run these. So they're both doing the same thing, but one is using pandas, which does not use Spark's distributed processing, and another one is using a Spark read, which will use Spark's distributed processing. So pandas will only run on the driver node, whereas Spark will run, will distribute the jobs amongst the different work nodes that we've provided. So we're going to see the difference. In this case, it's difficult to kind of see the benefits of Spark's kind of distributed processing. It's a very small data set, and so, well, actually, relatively small for what Databricks can load in. And so essentially we can't really see the difference, but what we can see is we can see how this has been divided into Spark jobs, which the pandas load has not. And now if we click view, we get quite an interesting view here, where it's going to show us, as you can see on the bottom here, it's going to show us how the tasks were distributed amongst the executors. So as you can see, it's provision 2 executors. So we set an auto scaling between 2 and 8. For this use case, it only provisioned 2, as it deemed that appropriate. And then it's distributed the tasks between these 2 executors, as you can see here, and none have been completed by the driver. These results are just reported back to the driver. So that's just a little view of the difference between Spark and pandas in this case. So next, what I'm hoping is going to happen. So Robbie is going to show us how we can collaborate. Multiple users can collaborate on the same notebook. So I can see here that Robbie is now logged into this notebook. I can see that at the top. And any changes that he makes are going to be displayed to me real time, and the outputs will be demonstrated real time. So what we've done here, Robbie has loaded in some JPEG images that we had stored in a storage layer. It's some places Liam would rather be than at his desk. I'm sure we all would at the moment. And essentially, this is just really useful for allowing multiple developers to collaborate on the same notebook at the same time. And there's a final interesting feature here which I'd like to show. So this is called the revision history. And what this allows us to do is view snapshots of the notebook at different points in time. So I can see here that Robbie has made this change, and then it's snapshotted this notebook at this time with Robbie's change. Now I can go back and view a snapshot before Robbie made that change. And if for example, this was, a change that I wanted to undo, I could restore this previous snapshot. And so you can imagine how this would be useful just in terms of if there's lost changes and you want to revert back to a previous point in time, just to see those changes. This is really useful for that. And you can always restore back to a previous point. And a final point here, just to touch on, there's an option here for connecting to Git. So this would enable you to use a kind of Git repository for code management, which can be very useful. Right. So now I think I'm going to hand back to Robbie, and he's going to take us through a couple of architectures which could use Databricks as their core ETL tool.
Yeah. Thanks, Liam. So as you said, I'm going to discuss sort of common data architectures and where Databricks fits into that. So here's a sort of common data architecture, there's obviously different sort of patterns and shapes and permutations of components that you can use, but this is quite a common one. And I've represented it as it would be in AWS. So hopefully you can see my mouse here. We have our source files that are going to be loaded in just as they are to our data lake in our bronze layer. And we're just going to take them in as they are. It doesn't matter if it's a load of irrelevant data. If we think it could ever have any use, that's loaded into our data lake. It doesn't cost that much to keep it. And then as we sort of move from bronze through to silver, through to gold, we want our data to become more refined. So we want it to be cleansed. We want it to be transformed. We want to perform the right aggregations. And that's where we're going to lean on Databricks to be doing that. We want it to read data from the bronze layer and move it to the silver layer. And then when it's in the silver layer, we might want it to get rid of some nulls or join to a different data set, or provide some sort of summing of measures as well, so that by the point it's in gold, we can then just push it to RDS or Amazon Redshift, so a database or a data warehouse, and then from there we can use that as sort of our reporting connection for our front end tools or for any sort of machine learning as well. And that's where Databricks comes in handy. It is the sort of chief transformation tool. Likewise, you can follow almost the exact same shape in Azure. So the only thing that's changed is the data lake storage is going to be different, but you're still going to be able to use Delta files, which are essentially just version Parquet files with a Delta log. But we'll not get into those until part 2 next week. And our database and data warehouse components change. So our data warehouse would be the Microsoft's new Azure Synapse. But the best way to show this is through a demo. So that's what I'm going to do with Azure Databricks. So this is the notebook I would use. It's called Architecture Example, Read Source, and Write to Process Layer. And that's all it's going to do. But I'm going to run it through ADF, which is our orchestration. So ADF is the sort of Azure component that would plan and organize all the sort of data movements all the way from source through to that SQL layer. To set up some parameters we want to pass in through ADF, we're going to set up widgets. So it's a collapsible thing. Important widgets and libraries, it's sort of a formality. So we can hide that if we want to get to the sort of more important code to do with the transformations. But just to show that passing in, so as a parameter, I've set the notebook path here. And then this is sort of my Azure Data Factory workspace, where I can have different activities. So I can copy data. There's a whole load of different ones. But in this one, I'm going to call it Databricks Notebook. I'm going to take the path from the pipeline parameter that I just showed there, and I'm going to pass that in. I'm also going to pass in these values here. And I'll hit debug, but it'll run. But just to show what we had earlier, if I can get to it, is that whenever it actually runs, what I'll be able to do is click here and actually view it running. But so it'll show me the sort of the notebook that I just kicked off with ADF and how it's running. So you can see it's done those first 2 commands, and then here it's reading in my source data in CSV format, and it's taken the source fact path, which is coming from the widgets, which was passed in here. So you can see how it's coming all the way from where I hard coded it into Data Factory into this read command. Just to show the one I did earlier so we can see the results of files. There was my read. You can see I've got my fact data, a lot of sort of attributes in the sort of first half and measures in the second half. And then I've got an extra dimension, which does have the 2 same columns, but we'll come to that in a second. I wanted to show the sort of ability to change languages, that if you're more comfortable with SQL, all you have to do is read in your data frame, put it to a temporary view, and then you can, select distinct company from view fact. You can just use your sort of data, your SQL code as you want. But all we really want to do between this layer of what we're calling source to processed rather than bronze to silver, is to change it from CSV into Delta files, because Delta is going to work faster and it's more reliable. In the next step, once we've written it to our process layer, we want to read from there again. So we're going to read the files we just wrote with Delta. And we're going to cleanse the data. So as you can see here, I ran a sum group by month and type. So you can see that actually there's this empty type that if it comes through in report, it'll be blank or something. And it's actually got significant enough values. You can see like there's 9,000 there in 2017-09, I think it is. So what I want to do is just, for reporting purposes, I'm going to switch anytime it's null in type to other. And then now you can see if I run the exact same command, it's now called other, which just gives a label to it and makes it easier to analyze. Here I'm going to display my data. As you can see in my fact data, something that immediately jumps out is that we've got countries called Lille. That's not a country I've heard of. So I'm going to check and just see what are the whole countries that are listed available, and Lille is set for everyone. But thankfully, we've loaded in our channel, which maps channel descriptions to country descriptions. So basically what we're going to do is replace that column which said Lille with the actual countries, and we're going to know which country it is depending on the channel description column that we have in our fact data. So we're dropping the country description which was Lille. It was irrelevant. And we're going to join on channel description, and it's going to be a left join. So we're going to keep everything we had in fact. We're basically just updating the country description column. And if you look at the result, we've got Swiss med chemist, and it's in Switzerland. And then what we're going to do is just write that transform data to our enriched layer. So that's the final layer, the enriched layer. It could also be called the gold layer. The certain naming conventions don't really matter. But we're writing it to our enriched layer. And then what I'm doing here is just creating a table off of it. And I want that table because I want to be able to view it within the default database. So I called it table if not exist table fact, and basically build me a Delta table on top of the Delta files that I've just written out to the enriched path. So it's essentially my fact data that's in the enriched layer, but it's now in the table format, and you can see it just here as table fact. And the importance of putting it in a table, you don't really need it if you're just going to use the sort of old data architecture, if you're just going to use this. But actually what I want to do is show Databricks capability to act as the sort of base source for your data visualization tool. So actually we're skipping out that sort of that semantic layer, and instead we're just going to use our Databricks database. And then just to show that in action, I have this Power BI workbook available, and I'll just show the connection to it. So if I just click on source, so you can see it's an Azure Databricks source. I've entered some information and I'm directly querying the data. So I'm not just importing it, I'm actually going back and referencing it. The actual source itself is, when it comes up, is just called Azure Databricks. So if I just type in Databricks, it comes up there. So that's the one I've selected. And then all I had to do was navigate to my table fact in my default table. And so I'll just leave transform data. I haven't made any changes. And this is what I was able to build out in terms of visualizations. It used the transformations that we built out. So we have a slicer of the different types. So we're allowed to now look at the other and see how it's changing our data. And it's actually showing volume split out by country and split out by our top 5 companies by volume as well. So there you can see we had data in our source, we moved it and wrote it as delta to our process layer, then we cleansed it, which allowed us to have this other value to select. Then we transformed it, which allowed us to actually have countries to split it out by in a visualization. and then we connected by direct query straight from Power BI to Databricks. And so I realize we're slightly over time, but just back to the slides to close up. If this interests you, how can Thorogood get you started? If you want to sample the functionality yourself, feel free to set up a Databricks community account. It's completely free. It is single node, so it won't run quite as fast, but it's useful to see the functionality. We offer Databricks taster workshops. We have details on the next slide if you want to get guided hands-on experience with the tool. We can help set up Databricks and other cloud capabilities at your organization. We can even run a proof of concept once we've sort of identified any key use cases that we think Databricks could bring real value to, and help you sort of set up a low-cost proof of concept to see how Databricks and the wider cloud technology could work for you. And then, of course, we can help. We have previous experience designing and implementing overall enterprise data architecture in the cloud as well. Either, every situation is different, but often Databricks is the sort of the tool of transformation that we think is best for the job. So as I alluded to, just to talk to some upcoming events. So next Wednesday, Microsoft and us are doing a joint launch panel on Azure Synapse and Microsoft's new tool Purview. Come back next week for the second iteration of this. We'll dive a bit deeper into some different aspects that we lightly touched on. Get more from your finance data with Thorogood and Databricks. It's a really good webcast, I think, hosted by my colleague Andrew. Anaplan Power BI connector is a really interesting development that's worth taking a look at if you're interested in the planning, business modeling, plus the sort of data visualization side and the combination between the two. The Databricks Taster Workshop, and that's the one that'll let you get hands-on with the tool, guided by our consultants. We are running a later iteration in early summer as well. And then also, if you go on thorogood.com/events, you'll find a whole host of workshops in all of our sort of separate countries, UK, US, Brazil, and Singapore, that you might find useful. Dashboards in a day, analytics in a day, Databricks Taster Workshops. All run virtually, of course, but all still really, really personal and interactive as well. You can learn a lot from them. And then thorogood.com/perspectives, there's a lot of sort of recordings of webcasts like this one. There's blog posts and there's case studies as well. So there's a bit of reading, a bit of watching of sort of our previous material if you want to look at that as well. Otherwise, thank you, and I'll see you next week.